So IPv4 IP addresses are divided into 5 classes. Okay, so 5 classes. So they are like A, B, C, D, right? A, B, C, D, E. So within that 5 classes, class D is reserved for multicast. Okay, and class E reserved for future use. Okay, future use. And you have A, B, C left for your own purpose. It might be giving it to your LAN IP address, it might be your public IP address, whatever, private, public, right? So what we will do is in the available class ABC, we will divide them into private and public. Okay. And whatever is left after private IP address are consumed, leftover of private, leftover of private will be taken by public. Public. So you already know the range, right? Yesterday we discussed class A range 0 to 126, and then class B is 127 to 191. Class C starts from 192 to 224, 223, 255, 255, 255. Right? So in those three classes, we will reserve certain portion for private, and then leftover is taken by the public. So in class A we reserve 10. You just have to memorize it. Okay, 10, 10, 10, 10 to 55. So class A's range subnet mask is /8, correct? Class B starts with 172.
These are the private addresses, right?
Correct, correct. So you don't have to mention the public IP address. So whatever is left over after the private is public.
Okay.
72, 31, 255, 55, 55. That's 16. So class B private IP address will have a subnet mask of /60, right? And then you have 192,
192.0.0, then 223.255.
no. The private IP address range.
Yeah.
Right. So that's why you need to understand what are all the classes first. What are the class range? So class range is the all the IP addresses available. Yeah, class A, B, C, right? So A, B, C, D, E, D and E, we know they are like used for separate purpose, right? We know the ranges. Just leave them alone. And then we pick ABC alone. Within that ABC, we divide them into private and public IP address. So in that private, in that division, private is going to take away these ranges, and whatever is left over after these ranges are public. So we call these ranges as RFC 1918. Okay, so RFC is nothing but it is like a standard. Okay, so like a patent, like accepted by the network industry. So for example, if you're going to present a paper, right? So when you're presenting a paper, if the paper is approved, then when it is accepted as a fact, and when it is going to be implemented across the solutions, right? then you would be given some id, correct? Like, so like that in networking. So whatever the facts, whatever the, for example, some tomorrow if you go and discover some new protocols, right? Like standard stb protocol, bgp protocol, or osp protocol, and if it is accepted by the network community and it is standardized, then that protocol will be given such id, rfc 1918. It is a standard.
Yeah.
It is a standard. So, private IP address, the way how we have designed and accepted the private IP address falls in this change. So, falls in this standard RFC 1918. So, tomorrow someone comes and asks, hey, you give some IP address from RFC 1918, then it means they are talking about the private space.
Okay, and what is the difference between public IP addresses and private IP address?
I'll tell you.
Oh,
You know what are all the private IP address and what are all the public IP address, right?
yes, range.
Number wise,
I know
range
those.
wise, number wise, you know that. But when do we use it? What is the purpose of it, right? When you are going to use, so the IP address that is going to be assigned between the router default gateway. Okay, this is the default gateway because that is the exit point for a LAN network. Okay, between default gateway and host, you use private IP address. That is within LAN. In your LAN network, local area network, the IP address that is going to be used is private. And whatever you are going to use outside your network,
Okay,
that
okay,
is
okay.
WAN, right? So you use public. Okay, there is one small exception. When you are going to, yesterday we have seen this topic word or term called
Yes,
MPLS, correct? So when you are going to use MPLS, you would still use private IP address here. The MPLS is a different technology. For now, you ignore it. Okay,
yes,
when you are going to use MPLS, both your LAN and WAN. I'm not going to differentiate with the word private and public, but I would say LAN and WAN. Inside, outside your network, it still be using private IP address. Okay, that is an exception with MPLS. So MPLS is a different technology. That would take a separate set of classes that is not in your CCNA syllabus. Okay, it might come in some CCIE level concept, not even in CCNP. So for now, just understand private and public. Private IP addresses are used in LAN, public IP addresses are used in WAN. Okay. Next, any other questions here? You are clear with the classes?
yeah.
Then classes
But
are divided into.
is there a concept like this wherein classful addressing was old concept and subnetting is the new one, or
No,
CIDR is
class.
the new one?
See, classful means yesterday we saw something like FLSM, right? Fixed length submitting mask,
Yes,
right? You remember this term, fixed and
yes,
FLSM, fixed. So it means classful. Next you have classless. Right? This is called variable subnetting mask. So classful means it is talking about full subnet mask 16, 24. Okay, classless means something like 10. Whatever is not the whole of 8, multiples of 8, right? Because IP address is divided into 32 bits, right? 4 octets, correct?
okay,
10 dot 10 dot 10 dot 10, right? This is how the IP address looks like, correct? So each portion you call it as octet, correct?
yes,
So octet means 8 bits, so 32 bits, correct? So whenever you are going to have a subnet mask which is a multiple of 8, then it is classful address. Okay. Whenever your subnet mask is not multiple of 8, it can be 10 for class A, and for class B it can be 18, 19, 20. For class C it can be 26, 27, 28, right? So they are classless because when we why we say classless, because they are not multiple, they are not a whole octet, they are not representing whole octet. Instead, they break the octet for some portion into network, for some other portion into host, remaining portion into host.
Okay.
So when you are talking about CADA, it means it is talking about a classless inter-domain routing.
Yeah, that is what I remember from my old classes that I have that dividing the network into classes, class A, class B, class C, class D, E is the old concept. After that, they introduced new concept which is CIDR, and then in that CIDR, you use subnetting to divide the networks. This is what I remember.
So old, we let's not say old concept. This is still existing. Okay, when we say old concept, we would think like it is an expired one. It's no more used in the industry, right? So it's not like your classful is expired. We are still using it, but just that we would go for a smaller subnets based on the requirement. So we have, so when you say classful, it is the first feature in the subnetting which was introduced, and then we went to classless. It's like a more advanced or more granular way of allocating IP address. So both still exist. I mean, classful and classless, they still exist, but classless is little advanced. It is because it is derived from the classful. So first you need a classful address to derive your classless. So both needs to be present. Okay. So classful, when I say they're like multiple of 8, 8, 16, 24. Classless is something which is going to break your octet into a few portion into network, few portion into host.
Okay.
Okay. So yeah, any questions here? Like before we jump into subnetting?
So basically, what you're saying is the class concept which was there, it is still present as well. We have not
Correct.
completely abandoned, but if we are using, my question is, if we are using subnetting, then what's the point of having classes then? Because we are dividing the network in using the subnetting, right?
Classes means you are talking about class ABC.
Yes, yes, yes.
Okay.
Because
So
using subnetting, we are dividing, and the main point of class is to divide the networks.
no, 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 no. That's not about main point of class. See, classes represents from class A to class C. It's going to give you 2 power 32 IP address, right?
Yeah.
2 power 32, because it is a 32 bit, correct? 2 power 32. So from class A, first address of class A to the last address of class C,
4 billion addresses.
right? 4 billion addresses. So 2 power 32, right? Now what we have done is we have we have, just for a easier management purpose, we have divided them into multiple classes just for our usage,
Yes.
like how we are going to leverage it, right? So class A, B, C, it is still not subnetting. Okay, so class A, if you think about class A, it has 2 power 24 IP addresses for your usage, right? Because we are going to use slash 8. Okay, so when we are going to slash 8, if you minus slash 8 from the 32 bit, it gives you to 24, correct?
Yes.
So you raise it to the power. So in class A you have 2 power 24. Similarly for class B you have 2 power 16. Then class C you have 2 power 8 IP address, correct?
Yes.
So it is just a portion of class A, B, C. Okay, it is not representing the whole section. So the way, what do you mean by subnetting is, uh, you have, let's say, let me just erase this diagram. Instead of this, let me erase this. So you have this range, right? Let's say it is class A, right? So you mean you have these many chunks, okay? So class A has multiple subnets, right? Uh, Class A has a 10 power, 2 power 24 IP address, okay? So let's say we have divided them like this using /8, okay? So you take this portion and use it for your reference, right? So this portion is a subnet, and this is complete class A, whatever you have. This is one portion of /8.
Okay.
So class A is just like a whole chocolate bar, and subnet is just a portion of it.
Okay. So for class A, we said earlier the range is from 1.0.0.0 to 126.255.255, right? So
Correct.
each of the each of the big class A network will have 2 power 24 hosts, like we said. But can we say that
Correct.
there are only 126 big host networks that are present for class A? Obviously, each one is having 2
120,
power 24, but there are 126 just such networks, is what we can say, right?
126 networks. How did you derive that value?
Because from 1.0.0 to
Oh, you're talking about, okay, okay, okay.
126.255. So
Okay, you're talking about
each of the 126 has 2 power 24. That is okay. But my point is
you're
that
talking
there
about
are,
this.
yes, yes, yes.
Okay.
So my point is that each of the big networks has 2 power 24 hosts, but there are
Hmm.
126 such networks, is what I was saying. Because,
So, so to derive that value, uh, 2 power 8. So you see the subnet mask, right? So it talks about number of networks that you have. So what is 2 power 8? 256 networks.
yes,
Okay, not 126 networks. Two. So you can have 256 networks with each network having 10 power, sorry, 2 power 24 host.
okay. Hmm.
This is host. 2 power 24 host in each network.
Yeah, I was thinking instead of 256, it is 126 because
Hmm.
not going by the subnet, but just going by the IP address. Because one,
No,
it
no,
is
no,
running
no, no,
from 1 to 126. That's why.
no, 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 no. It's not like that. So how would you? So let's say this is
So
one range,
first
right?
one will be
When I say
from 1.0.0.1, 1.0.0.2. Similarly, I will get for 1.0.0.0 till 1.255.255.255. So that will be
see,
one big network, is what I'm
I'll
saying.
tell you how I'll tell you how it is going to increment. Okay, so I didn't explain you how you are numbering, right? How you are going to increase the host, right? So let's start. The first host starts with, so it's a /8, right? So this portion is going to remain static. It's not going to change, correct?
Yes, yes, yes.
Only the remaining portions will increment, correct?
Yes.
Okay, this is the network ID, right?
Yeah.
The next available host is 1.0. So
0.0.1.
1.0.0.1.
1.
Okay, you
Yeah.
can go up until
1.255 or 255 or 255.
no, 255, right?
Okay. Okay.
So let's just go like 256, 256,
Okay.
because
Okay.
to the maximum number it can go, right? It's just 255, correct? And then what you do, you increment. Next it starts with 1.0.0.1.0,
Yes. Yeah.
right? It goes like this, 0.0, sorry, 1, and then 1,
1.1.
correct? And then it ends like 0, 0, 1.255,
1.255.
correct?
Yes.
Similarly it becomes 2.255
Like that,
until it,
one will have 2 power 24 host.
correct, 2
Yes.
power 24. So each.
Yeah.
So
So
when you're going to give 1.00/8, right? So you will cover these many hosts. This is how you increment. And
okay.
then you move. Then you, if you want a different subnet in class A, let's say you have consumed this network. What is the next subnet? 2 dot, right? Correct.
Yeah.
2.8, because I'm changing the static portion. When you change the static portion, it's a different network, right? The static portion slat indicate the network portion, correct?
Yes.
So initially I used one. One is my network, rest all host. So one represent my network portion. So if I have to go to a network, different network, then I have to increment it to a different value. Correct? Increment, change, replace, whatever. 2. This is a different network for /8. For similarly, for another network, you'll use this 8.00/8. Correct.
Yes.
So let's take class B. Okay, 172.16.0.0/16. How will you increment this? Let's discuss about the host portion.
Okay.
172.16. You will keep this 16 unchanged, and then you will increment like this, right? 172.16.0.1 up until 172.16.0.255.
Yeah.
Correct. And then you will increment 172.16, because it is 0 now. 1.0, it is, you are still not changing the network, it is still your host portion, right?
Yes.
1.0, and then 1.1, 1.255. So this will continue until you have 255, 255, 255. The start with 255.0, and then it ends with 255, 255. Correct. So you will have this two portions reserved for network, sorry, host, and then these two portions reserved for network. So this is how
Yes.
the numbering goes. So you
Okay.
can't pick this 126 and you can say 126. So you have to do this calculation. So 16, when you say 16 bits for network ID, and then memory 2 power 16. What is 2 power 16? It would come around somewhere
65,000.
65. Yeah,
65,000.
65,000. So 65,000 networks are possible with each network having 65,000 IP address.
Okay.
Okay. Same is the calculation. Can you tell me for class C /24 how many networks and how many IP addresses are possible? This is /24.
Yeah. 2 power 24 networks are possible with each network having 2 power 8 hosts.
Correct. Okay.
Okay.
Now you understood a little. You have got some idea, like little bit of idea from
Yes.
yesterday about class A, class B subnetting,
Yes.
right?
Yes.
So we have not gone into the calculation of subnetting, but why we need, what is this subnet? What is this class A? What is this classes? What are private public? You're clear, right?
Yes.
Okay. So let's take the same example, like, right, 1.0/24. Correct. So I need the broadcast ID. So this is class full. Okay, class full. So how many IP addresses are possible? 248, right?
Power
Because
8.
32 minus 22, sorry, 24 is 8. So that will give me 256 IP address. So in this 256 IP address, two are reserved for network and broadcast portion. Remaining you are left with 254 IP address. Okay, and the host push the network ID is 192.168.1.0 because it is the first IP address of the network, and 192.168 1 dot 192.168 1 dot 255 is the broadcast portion. Okay, rest of everything is false in between is a usable host range. Okay, 1.1 to 1.254. Okay, so this is the basic classful. So these are the details that you can extract. If someone gives you this subnet with the subnet mask, these are all the things that you can explain it to him. Okay, so these many addresses are possible, two are reserved for the special two purpose. Then usable range is 254, starting range, ending range, and what are the usable range. Okay, so this
Yeah.
is classful. Now let's get into classless. Okay, if you understood this clearly, let's move to the classless, which is called as variable and subnetting mask or CIDR, whatever.
Okay.
Let's take the same example 1.0 slash 28. Okay, why I'm saying classless? It is not a multiple of 8 now. Okay, so if it was a multiple of 8, it will reserve the whole portion between each dot or in each octet, right? So now when I say slash 28, 8, 8, 8, right? Uh, this 8 is here. 8 and then 4 plus 4, right? So this will combine and make 28, correct? Rest is 4, right? You're with me?
Yes.
8, 8, 8. I'm dividing this octet. Octet means 8 bits. I'm dividing this octet into 4 plus 4 so that it aligns with 28 subnet mask.
Yes.
8 plus 8 plus 28. And then I'm rest. So it means the network portion is 28 bits and the host portion is 4 bits. Correct. So 2 power. So let's do this calculation. 32 minus subnet mask is going to give me 32 32 minus 28. That gives me 4 bits. I will raise it to the power of 4 and derive 18. So it means 16 host is possible with each network.
16 minus 2?
Correct. 16 minus 2 will give you the whole usable host range.
Yes.
Usable host range. So now I have to determine what is the range, right? I have derived the calculation, I have derived the value. It's just like a number, but I need to get the whole output. Like what is it then? So you told me 16. For so far, we have been dealing with multiple of 8 to power 8 to power 16. It starts from 0 and ends with every octet starts from 0 and ends with 255. Correct. So that's what we have seen. 0 to 255. That is the maximum value which can start and end with an act. But now you have given me 16. Previously it was 256 with classful. Everywhere I saw only 256. But now it has come to 16. How we are going to give it? So 16, it starts with 0, right? And ends with 15. Correct. I say 16
Yes.
starts from 0 and ends at 16. 192, 168, 1.0. Easy. It goes until 192, 168, 1 dot 15. This is my range. So this becomes network ID, this becomes broadcast ID. Whatever is in between, they're usable host.
Mhm.
Okay, this is easy because someone has given you a network ID, right? And you are able to calculate it because when you start with the first number, it is easy to just count with the usable host value 16, right? And then you stop at 15. That is easy. But the problem is, so you have this whole octet, right? So this is 0, right? It starts from 0 and ends with 256, correct? This octet,
Mhm.
right? It starts with 0. The maximum it can go is 256, correct? In general, leave about this case. In general, when you're using slash 24, right? You're with me?
Yes, yes. For general, for slash 24, we have 2 power 8 host available. So it ranges
Correct.
from 0
0 to
to.
56 range. Every octet range is, so every octet is 2 power 8, right? So 2 power 8 is 256, correct? So you, when you represent with the actual number, it starts from 0 and 256, correct? So what we have did now, we have divided into 2 power 4, right? Slash
Yes.
28,
Last
right?
4
2
digits
power
are
4,
available.
correct? So it becomes 16, correct? Now we have to divide this portion into 16, 16, 0 to 15, 0 to 31, 0 to 16, right?
24
Let's see
plus
who,
4.
uh, 16 means 47, right? It goes until 63, right? So similarly, it goes until 256, correct? So now we have covered 0 to 15, right? And the next subnet is 192, 168, 1 dot 16 slash 28. Any questions?
I didn't get this part, last part that we're trying to do. So I
That's what.
understood till the 16 hosts that we have, and first dot 0 and dot 15 are network ID and host broadcasting
Right.
address. After that, you told let's forget that we are doing slash 28. Let's just say the slash 24. Then that is the last octet that you just drew, right? On the table on
Yes.
the screen.
Mhm.
Okay. And after that,
So I drew this diagram, correct?
yes, yes, that is the last
So
octet.
with, correct, last octet. So that is the last octet when it was slash 24, correct?
Yes, with the
So when it
slash
is a
20.
slash 24, you have whole portion is reserved for the whole subnet, right?
Yes,
192, 168, 1 dot 0 means you can start from 0 to and end with
correct,
256, right?
correct.
This whole portion is static,
255.
correct? It is for slash 24, correct?
Yes.
Right. So let me just erase this. Okay. So 192, 168 is a class slash 24. I'm reserving these three octets for host portion, which will not change, and it will give you a range 0 to 56, right? And this is the diagram I was using it for your representation. Correct.
Yes.
Okay, it starts from 0, 15, 31, 47, 63, and then it goes until 256. Correct. So now we are going to a classless. It means we are dividing this network, right? So this is my main portion of it. This is my original class C, and so how many networks are possible here? So slash
So,
24, it's
hmm.
okay. Now we are breaking it into 2 power 6, 2 power 4, correct? It gives me 16,
Yes.
correct? So how many such networks are possible here? You're reserved with, let's say, remaining, you have 2 power 4, right? In the 2 power 4, you are going to 2 so you have increased 4 bits, correct?
Yes.
Correct. So you increased 4 bits. So 2 power 14. 16 networks are possible, right?
16
So
hosts.
I'm not going to say anything about this. 2
Yes.
power 24 host, right? So 2 power 24 host gives you some millions of value. No, I'm not talking about this. I'm
Yeah.
talking about going from 24 to 28. So you have increased 4 subnet mask, correct? So subnet mask talks about your network, correct? So we increased now value 4. So it means 2 power 4 will give you 16 networks in this main network.
Yeah. 16 hosts you can say, right? Not network.
No, no, no. I'm dividing, right? From 24 to 32, you have
Okay.
8 bits, 8 octet. Sorry, 1 octet, 8 bits, correct?
Yes.
I gave 4 octets to the host, subnet mask. It became 28,
Yes.
correct? 4 octets to the subnet mask, so that's why it became 28. So whatever is subnet mask is representing the network segment, correct? So network segment has become 2 power 4. You can get 16 networks from this main network.
Okay.
And host, the remaining in 32 bit, you gave 28 to network segment, and what is left? 4, correct? 2 power 16 is host. Let's say, so since I'm equally dividing, right now you will find it confused. Let's go to some odd number. Let's say slash 29.
Okay.
What is the network portion from this 24? You have dividing into 29. So I have increased the value, means I'm dividing it. Okay. So 29 minus 24 is 2 power 5, correct?
Yes.
So 2 power 5 goes for the network segment. What is 2 power 5? 32,
Yes.
right? And then what is left for host? 2 power 3. 5 plus 3, 8, correct?
Yes.
So you can have 8 hosts in each network. So you can have such 32 networks.
Okay.
Clear? So
Yes.
let's take this example. I'll go with 8 only. Okay. 192, 168, 1.0. I'm saying 29. So my starting range would be, so what I did is I divided this whole octet into 5, 2 power 5 for host, and 2 power 3 for, sorry, 2 power 5 for network, 2 power 3 for host. Where 2 power 5 for network, 2 power 3 for host. So it means 8 bits, right? So it starts from 0 to each each host portion will start from, let's say, 192, 168, 1.0, and 192, 168, 1.7 host portion, correct?
Yes.
And I have 32 such networks, correct?
Yes.
My next network will start like this: 192, 168, 1.8, and hence you add it to the value 192, 168, 1.15. Any questions?
No, no. I think it's okay.
You're following?
Yeah.
You get the logic, right?
Yes.
We are not doing a class full network, so that was easy just to define it. Now we are breaking into the socket, so that's why a single 0 to 255 was a whole usable range before. Now we are breaking them into small networks. So a small portion in this 0 to 250 range is belonging to one network here. So similarly, the next range starts 168, 1.16, and then 192, 160, 1.23. Okay. Network ID, broadcast, network, broadcast, network, broadcast.
Oh,
Okay, do you like to do a math for this? 1.0/25.
Plus 25, right?
Hmm.
Yeah. Um, I think first one, so we have how many? 2 power 7 available for the number of networks hosts. Yeah. So
2 power 7 is 2 power 8, which is
128.
128. Correct. Then 2 power 1 is network, which is 2. So only 2 networks possible. So in the previous case, 32 networks possible. So now you have only 2 networks. It's easier compared to slash 29. So what are those 2 networks?
Um, so one will be from dot zero.
192, 168, 1.0.
Yeah.
Okay. First starts with 1.0.
First one, yes. Then it will run till 127.
Good. Okay. What is the next network?
Then I think it will start from 128 then here.
Exactly. 128. And you add 128 host, it becomes 255.
Yeah.
Right? Yeah. This is what variable subnetting. You break this slash 24 into smaller subnets by increasing the value, and then whatever you increase, that becomes host portion, and whatever is left over becomes, sorry, whatever you increase becomes the network portion, and whatever is left over becomes the host portion. So you divide like this, right? So now you would be able to do for slash 28, right? Because slash 28 had some little confusion because they were like equally divided by the network and host portion. So
Yes.
you are not able to clearly identify. So when you have some difference, like this one is higher, this one is lower, right? The vice versa. Now you are able to identify. So
Yes.
do you would be able to do this for slash 28 also, right? Take this as a homework.
Okay.
Okay, for slash 28, 192, 168, 1.0 slash 28. This is your homework. Just
Right.
see what are all the usable ranges, how many networks possible, how many hosts is possible in each network.
See.
Okay. So this is what networking. See, next thing is right. This is usual max. Okay, like a theory in a production in a live environment. So nobody is going to give you 192, 168, 1.0. Tell me what are the IPs. No, this is student stuff. Whatever we have seen, student stuff. Now let's get to the real man stuff as a network engineer. How you would face the problem at production. See, if I'm going really fast with the topics and just to tell me, I will just slow down. We can slow down the topics for a day and just go one by one. If it's too overwhelming, okay,
Okay. Think,
we can slow down. No problem.
yeah,
Hmm.
can we continue this tomorrow? I just have some other office work to do as well.
Yeah,
That's I
no
had to
problem.
see.
Okay, that's okay.
Okay.
That's okay. So for now, this is okay. But yeah, just practice this and let me know if you still have any questions. We'll clear this out because after this, we will not see submitting. Other topics are fine. We will reference one or two later, but submitting is done. So you have to be really clear before we move out of submitting. Okay.
Okay. Sure.
Okay, Mr. I'll see you in the next class. Like Saturday, Sunday, no class. Next class will be on Monday.
Okay.
Might which might be your Sunday evening, I guess, right?
Yes, for me it will be
Now
Sunday.
it's It's is it okay Sunday evening, or do you want to move it to Monday evening?
Sunday evening, actually, I'll be, let's see, Sunday evening at 9:30, right? Yeah, I'll be here. No worries. I can take the class.
Otherwise, we can have something for me like Tuesday to Saturday morning for me, and Monday to Friday evening for you. We can fix it
That
like
can
that.
also work, actually.
Okay, then we can stick to this. So we can have a class tomorrow morning, which
Yeah,
will be a Friday evening.
yeah, we can have.
Okay. Okay, then let's see you tomorrow.
Okay.
Thanks for your time.
All
Bye.
right. Thank you.